What is up, plant people? It's time once more for the Planthropology Podcast, the show where we dive into the lives and careers of some very cool plant people to figure out why they do what they do and what keeps them coming back for more. I'm Vikram Baliga, your host and your humble guide in this journey through the green sciences, and as always, my friends, I am so darn excited to be with you today. I got to go to a museum for this episode. Do you know how excited that makes me? Do you know how much I love museums? So this episode is with Dr. Aaron Pan, who's a friend and the executive director of the Museum of Texas Tech University. He's done a lot of things in the museum world, from curator to executive director at a couple of different places, but by training, Aaron is a paleobotanist, which means that he studies really old plants, but he also studies evolutionary biology and paleontology and all kinds of super cool things. This was a fascinating conversation. And honestly, I could have talked to Aaron for another several hours, and I might make him come back in the future and we can listen to him talk for several hours. But we talked about everything from the history of plants on different continents and how they move from continent to continent. We talked about evolutionary biology and what we can learn from the past about our future. We talked about palm trees. We talked about museum collections and museum life and how important museums are in our society and in our lives and in our culture. And it was just so much fun. Aaron's a great guy, brilliant scientist, and a wonderful director at this museum. So I don't want to belabor this too much. I want you to really dive into this episode. So I'm excited you're with me, and I'm excited I finally got to sit down with Aaron. And the more times I can go to museums to do stuff, I'm going to do that. So grab your tiny little brush or toothbrush or an electric toothbrush and your pick and a little scraper and a magnifying glass and whatever else it takes to find old plants and dinosaurs. And settle in for episode 121 of the Planthropology Podcast with Dr. Aaron Pan. Hey, it's actually future editing Vikram and not past talking to Aaron Vikram yet. Sorry about that. I know the other guy's better. Listen, I had forgotten that I had just gotten over a cold when I recorded with Aaron. So there's some weird audio stuff. We had some room mic issues as well, too. And it sounds pretty good. Everything's good. I have to apologize that there's a couple of times in this episode that you can hear me trying very hard to survive, and breathe. And I'm sorry. Anyway, getting into the episode. Recording. Okay. Well, Aaron, thanks so much for letting me invade your office and set up all my stuff. I realized as I'm unloading the car that there's no way to do this and travel light.
You've got a lot of stuff.
I always mean to I'm just going to take a few things, and it's just sort of evolved over time. But I appreciate your time this morning. I'm excited to talk about everything, paleobotany, the museum, and everything else. But just starting off, why don't you introduce yourself a little bit? Tell us where you went to school, what you studied, and kind of how you got to where you are.
Okay. Yeah, my name is Aaron Pan. I am now the executive director of the Museum of Texas Tech University. And basically, I've been really interested in, I guess my research is mainly focused in paleontology, paleobotany specifically, but I'd rather sort of call myself a naturalist because I don't know if I can't fully focus on one thing at one time or not, but we do a lot of, I actually sort of do research on other things as well, or more likely, I have some very kind colleagues who let me insert myself into to asking weird questions and then pursuing it, and they help me along with that too. So, that includes things like native bees, velvet ants, abalone systematics, sort of. It runs the gamut. But my first research love is paleobotany, and it sort of started. Went actually K through 12, Amarillo.
Okay.
Amarillo Independent School District. Went to elementary school, middle school, Amarillo High for high school, and then I went off to University of California, Santa Barbara, because I thought at that point that I was going to do marine biology and I was wanting to study whale evolution. So that was my first.
Okay.
And so it thought, okay, well, I'll head for the coast to do that. It doesn't hurt that UC Santa Barbara's campus is gorgeous. It has a lagoon. It has a beach. It has, and the dorms are right on the marine terrace.
See,
so
yeah.
it's absolutely stunning. So, not that Texas Tech isn't beautiful as well, but
Right.
the ocean views are a little to be wanting. So
yeah, we have like all beach and no ocean, endless sand.
Yeah, exactly. If we were here during the Cretaceous, we'd be good.
Sure.
Actually, yeah, so that'd be good. But went there for undergrad. What's interesting is if you go in biology at UC Santa Barbara to sort of weed out those who quote unquote can't cut it, you don't get to take a single biology course your first year as a biology major. You have to take chemistry, and if you can do that, then they said, okay, now it's sophomore you can start doing that. So what I did was, and I really wanted to learn about organisms still in that time. So I actually became part of the College of Creative Studies at UC Santa Barbara, which is an interesting program where it's for those who know that they want to do graduate school after they graduate. And so what you actually get partnered with a counselor, mentor, professor who basically sort of determines what your schedule of classes will be. So it means that you can leapfrog. So it means that you may not necessarily have to take a preliminary course before you take the course you want. You can actually start taking upper division courses. You can start taking graduate courses your freshman year. And so I got to do that. So what was nice about that was that they let me take geology and paleontology courses my first year. And so that's where I really started to enjoy learning. And the professor who was my mentor, Dr. Bruce Tiffany, who's a very well-renowned paleobotanist, basically, he made it so exciting that basically I sort of fell in love with paleobotany at that point.
Okay.
And so after I graduated from there, I really thought, hey, I want to do graduate school. I want to do work in paleobotany, but I would really like to work in the tropics. So I'd love to work whether it was the neotropics, whether it was Southeast Asia and Malaysia, or if it was in sub-Saharan Africa. I'd really like to do that. And so I applied to schools, and an amazing professor, Dr. Bonnie Jacobs at SMU, offered me, thought I could be her graduate student at SMU. And she worked and she was very well known for working in sub-Saharan Africa. She had been working in Kenya. She lived in Kenya briefly. She worked Tanzania, and she was she knew Africa was her place to study. So I was very excited to work with her. And so I moved there in 2002, and then went to graduate school. Got my PhD in 2007, was there briefly for a postdoc. And then my first position was as curator of science at the Fort Worth Museum of Science and History.
Oh, well, that's pretty cool. That's a great museum.
Yeah, it is. It is. So what was nice about that one is that it is a multidisciplinary one as well. So it's got the science part, obviously in the name, and it's got the humanities part being the history part. So that was really cool as well. So
that's awesome.
And then from there, I also fell in love with museums. So that's sort of how it started. Both how research and
yeah. So and then I saw you were also, I guess, the director at the Don Harrington for a while as well. So you went home, I guess, back to Amarillo.
I went home one because I really enjoyed the Fort Worth Museum of Science and History, but I wanted to try some and grow in administration and things like that, and the Discovery Center was a great opportunity. One, that was also one of the places that actually got me excited about science in the first place. So that's kind of cool to, so like as a little kid, that sort of gets to spark you, and then you get to sort of, put your name on it, and you put a little bit of impression on there. So I was there for 8 years, and then I had the opportunity to apply here. And I couldn't pass that up because I missed doing
for sure.
I missed academia. I missed the resources and stuff that are available for an institution like this. And Texas Tech University is amazing, and this museum was amazing that it had, again, multidisciplinary. So my scattered brain loves that it is not just one. It's not just one discipline that we have a good expertise in, but there's multiple ones. And so that was that. So yeah.
It's interesting to hear you say that, and we'll talk a little bit more about the Tech Museum sort of in the back half of this episode. But So I grew up here in Lubbock. My wife and I actually both did. And we grew up going to the science spectrum here in town.
Uh-huh.
And so my wife, in her undergrad, Alana, did wildlife science. So she did wildlife and fisheries, but she focused more on collections and ecology.
Yeah.
And so then she was the education director at the science spectrum for quite a while. She worked there for 12 years, did everything from like the front desk to the animal room to a little bit of everything. Spent the last, I think, 5 or 6 years as the education director.
Yeah.
And or education coordinator. I don't know how they title them, but works there part-time sort of as a consultant now. But yeah, she tells the same story that like as a kid, like she knew going there and falling in love with science there, that's something she wanted to do.
Yeah.
It was like her dream job from the time she was a kid and then got to do it. And it sounds like you kind of had a very similar experience.
Yeah. And that's what's incredibly lucky, because usually, you know, how many times you actually get to sort of pursue, make a living from, stuff that you were really interested in when you were little. And so it's fantastic. That's great. I'm glad she did as well. So
so she spent a lot of time in museum world. So that was another reason I was excited to come do this, because like getting another perspective on it is really, really interesting to me. But let's talk a little bit more, I guess, here up front about the actual subject matter you studied, paleobotany, because this is so fascinating to me, and I know about this much about it. So I'm excited to learn a little bit more.
Yeah. So paleobotany is the study of prehistoric plants.
Okay.
And basically it runs from the origin all the way through, I would probably say by the end of the Pleistocene Quaternary. That basically counts the whole gamut of what paleobotany is. I've always really liked stuff that's near modern, but still somewhat weird and unusual. And so I really liked it with doing to sort of stay in the Cenozoic. The Cenozoic is from the end of, so basically from the abrupt extinction of non-avian dinosaurs, all the way up through today.
Okay.
And so that's what the Cenozoic is. And so, and for paleobotany, that would mean basically from the Paleogene or from the Paleocene all the way up through the Pleistocene.
Okay.
So basically, dinosaurs dead to end of Ice Age.
Okay.
Sort of, yeah. So that's sort of where I find it really fascinating. I think what is interesting also that many people don't realize with paleobotany, which is unusual compared to things like vertebrate paleontology, which is, studies, the prehistoric life of animals with backbones or invertebrate zoology, is because plants are always growing. They have meristemic growth. They always are producing, body part, basically producing body parts and then they're falling off. What's interesting is like you can't always tell if you have all these parts. It's if you find a leaf over here and you find a flower petal over here and you find a structure, a reproductive structure over here, like a fruit or a seed or something like that, you cannot necessarily say, oh, these all belong to the same thing, and I can describe it as such. And so that's where a lot of interesting, weird stuff happens, particularly for things that are further in the past. Luckily, with the times I'm sort of looking at, particularly during the Oligocene then through Miocene, it's not as hard. But that's why often you have what are called organ taxon, or where basically you have several things that are named different genera, but they may actually all belong to the same plant.
Okay.
Which is weird. And that often happens in things like in the Permian and Triassic, materials and stuff like that.
That's fascinating. And I never would have thought of that. Okay. I am speaking from a place of not just pop culture like paleontology, but that's a lot of the influence in my brain.
Yeah.
But like you have this picture, I think, or a lot of people probably have this picture of paleontologists going out and like, I found a whole dinosaur.
Yeah.
Right. And I know that that's not super common, but But I had not, but yeah, there's not generally just parts falling off a dinosaur, right? They're not running around like shedding legs and things.
Right, exactly. If it's dead, if you find a scapula of a dinosaur, you basically know,
right?
Yeah, it died at that point.
Yeah,
it was dead. So basically, you could have something producing, that's being, preserved, and it's still living for longer that you didn't know about, which is kind of an interesting thing as well. I think the other interesting aspect of paleobotany is that in many cases the taxa, like genera, have a much longer span of existence than things like mammals. I think mammals,
sure.
I don't know, I can't get the number correctly, and I will definitely be wrong, but it's really like genera are on the order of typically around average about 2 to 5 million years a genus exists.
Okay.
Before it even goes extinct, or it modifies so far that it's different. You have things that you have, flowering plants like Nothofagus, the southern beeches, and the Phagales, which are known, I think, back to like 80 million years ago. The genus itself, known 80 a genus like Homo, which is only known for what, 2 million years,
right?
Compared to a genus that's known 80 million years.
Yeah,
that's really interesting, and that's really fascinating.
And I think it's hard for people to grasp these time scales. Yeah. Just conversations I have with people about evolutionary biology and evolutionary history. We think, I don't know. I think there are so many misconceptions about like what time even looks like. And at some point, like our brains are just like a long time. I don't know. Yeah. And I think people struggle with that, but that's really an interesting thought too, that, before, the cataclysms that wiped out dinosaurs, like some of these species were extant, right? Like we had some of these plants that were maybe not in the form they are today, but hanging around.
Yeah. I mean, you definitely have families that existed back then, in the late Cretaceous that exist today. I think the other fascinating thing is that, and this is for just the paleobotany of the discipline itself, is all these sort of interesting things that you don't think about. So Australia today is, most people know it for, koalas, kangaroos, but if you were to talk about what is the quintessential plant that Australia is known for, it would be gum trees, eucalyptus, and allies. So that, gums, they're in every habitat. They're from these tall sclerophyll forests to, scrub to, even very, very dry habitats. There's many species. It's like the quintessential genus, eucalyptus.
Yeah.
Well, you think, oh, it must have started there, or the oldest one must be from there. No, South America.
Really?
Yeah. There was a group that they've found some fascinating material in South America that's basically from the Eocene. And they've got beautiful things with fruit attachments and preserved leaves. Yeah, eucalyptus. You would not think, it may have had its origin in South America.
Right.
So it's a fascinating thing that you have an idea about what may be existing there, but you can't be fully for sure. We'll go into a little bit later when I start talking about, like African forests and stuff like that. But, the tropical rainforests that you have in Southeast Asia today that are found in the archipelago in Malaysia, as in, or Melanesia, you would think, the main quintessential tree that's sort of known is the family Dipterocarpaceae, which is I don't know if many people know about it, but they're a very important timber family. They basically sort of cause the really great structures of these forests. They're these gigantic trees that are can be tens and tens, and maybe even hundreds of meters up in the canopy. What's interesting is they often lose their lower branches. So they have these nice cylindrical poles without much quote unquote, I guess would be flawed for the timber industry. So they're really cut down a lot. So,
interesting.
Yeah. So, that's where some of those forests are sort of being threatened, but also because they often drop their lower branches pretty quickly. That's why you have probably the evolution of some of these really amazing like animals there. Why do you have, that's why those forests have things like flying snakes, which are not obviously flying, but they're opening up their ribs and they're spreading out and they're moving. They're basically slinging themselves and gliding from tree to trees. Over tens to 100 meters. The same thing with things like colugos and flying squirrels and Draco, those gliding lizards, flying lizards and stuff like flying. Yeah, and so that is what's really so plants are actually causing them, and they're the quintessential family there. They likely had their origin in Africa. And so basically, and it probably moved from Africa to the Indian subcontinent. The Indian subcontinent has Dipterocarpaceae and Dipterocarps today as well. Not often found in sort of in the known sort of things like salt forests and stuff like that. Not necessarily like rainforests, or if there are some that are in rainforests, but they're not necessarily the main majority, but they're found in these monsoonal forests and stuff like that occur in India. And then they sort of take off and become these sort of rainforest trees in Southeast Asia. So it's really unusual. And that, we wouldn't know that necessarily without paleobotany.
Right.
Really cool. And even today, it's always interesting, the pool of the recent and the bias that often has, past, or even if it's modified slowly. And so, but I think what's interesting is when these discoveries are made, like, that's weird.
Yeah.
And that's what's fun, I think, about this type of research.
Yeah. And you discover, I don't know, this incredible diversity of life that, in some ways today is poorly understood to us. And I don't know. I think we get like our conception of nature kind of pigeonholed sometimes. Yeah. And like, this is what is, and this is what's always been. We have this, again, incredible biodiversity over time and species that come and go and ebb and flow throughout time. And I think when people think about what does like a rainforest look like, what does a prairie look like, it's like, okay, when do you mean? And so we have in the like horticulture side of all this, we have this conversation a lot about native plants, like plant a native plant, okay. How far back do you want to go? Like when we talk about what's a native plant. So, in my mind, I think about what has close coevolutionary relationships with other species around, what has had the sort of time to acclimate to a climate, to a set of biodiversity, and then what doesn't like get out of control, what's not invasive, those kinds of things. Absolutely. Is that something that y'all talk about at all in sort of these contexts, is like what is actually supposed to be there? Because I asked because you were talking about like eucalyptus evolving and sort of having its origins on a completely different continent than we think about. And so like, where does that fit into this conversation?
Yeah, it's hard because again, it's sort of what does it mean? I'll take an example of some of our work. Africa rainforest today, and I'll say that I really, also my focus is when I was looking at Africa, is I really wanted to work on forest communities.
Okay.
I think part of that is because growing up in Amarillo and
sure.
and trees are rarity. I wanted to see, study those other, because again, I was always excited about things like going to Muir Woods or going to, seeing forests and stuff like that.
Sure.
They're fascinating. I'm also a short guy. so also I really, so I tall. So it's always a fun thing to, but, it's, if you look at African wet and moist forests, tropical forests today, and even in other habitats, the king and queen of all plant families making the woody structure is going to be the legume family.
Okay.
The peas, the beans, that group. That's the and hands down, probably within those forests, there is a subfamily of clade called Deuterioideae. And that one is also like basically the prominent one that makes up the canopy trees. That's the one that you have most of the, obviously African forests are very diverse, and they've got a lot of other plant species and families as well. But if you had to name one, it would be the Fabaceae leguminosae. The beans and that group. And within that group, the deuterioids. And so that subfamily had an amazing radiation and ecological dominance of these forests. And we can find back in in the work that we're doing in Ethiopia, we're finding that also back even in the Oligocene and prior to that. In fact, I think even in the Eocene, Dr. Jacobs and their team's work that they did at Mahenge, which is a marl lake around sort of, and they even find legumes back then. So, basically sort of making up there's at least 3 or 4 or more species known at that one place. So it's pretty fascinating. But what's weird is within those families, even if we know back that far and they still dominate today and they dominate back then, some of the players are different.
Okay.
So in Ethiopia, we have a site called Lush, which is from about 21.73 million years ago. So it's in the early Miocene.
Okay.
So this is a time period when early on in sort of ape and old little monkey evolution, stuff like that as well. In Ethiopia today, in the Deuterioideae, there's only a single species and genus, the tamarind. That exists there. And again, we don't even know necessarily if that was natural or assumed a planted, but that's the only one that exists there today. Back in that time period, there is a whole number of genera that don't exist in Ethiopia today that are there, but do occur in Africa now in forests. So there's a genus called Anglerodendron. There's a genus called Anthemotha. There's a genus called Newtonia that are all found at Mush way back then. Well, what's weird is, and that forest is actually dominated by this genus called Anglerodendron, which, it has, a handful of, it has, I don't know the number. I know it has more than 8 and less than 20 species.
Okay.
And so what's weird is that most of them are all now found in the Guineo-Congolian basin, found in, the forests in the Congo Basin. They're found in some of those forests in West Africa, and then things like Cameroon and Gabon, except for one species that occurs in the Usambaras, with part of the eastern arcs of Tanzania. So that's weird.
Yeah.
And so you're like, so was that, so had you not found it at Mush, you would say, oh, well, maybe what happened was it just this what Pan-African forest or something like that. And so basically this one little lone one that's in Tanzania, during the Ice Age probably got isolated. Well, we don't necessarily know that now. Because now if you have Anglerodendron that was found in Ethiopia way back in 21 million years ago.
Right.
And it's basically the dominant tree that occurs there. What was going on with that genus? So does that mean that more conservation work needs to be done to protect this genus because it did have such a much more importance ecologically even back then?
That's really interesting. So it's hard to know, right? It's hard to know in some cases because we're looking at it through the lens of history, right? Through biological history of, what was here, what wasn't. So an example that pops into my mind, and we're talking on a much smaller time scale here. I was out at the Lubbock Lake Landmark, which I think is part of your unit. Is that correct?
Yeah, part of yeah.
So for those that don't know, we have there's a native spring out there. It was an old lake, the headwaters of the Yellow House Straw that leads to the Brazos, heads to the Gulf of Mexico, right?
Yep.
But it's a paleontological site as well. So there's mastodon or mammoth bones there. Yeah,
and basically it extends. There's been it goes back to, as I said, the Ice Age all the way up through historical times. So basically had human occupation there for thousands and thousands of years that you have evidence of.
Right,
it's fantastic too. So
I was out there one day, and I think Scott, I believe out there, it doesn't matter, was giving me a tour and just driving me around, and it's really cool. And, there's this conception of a specific plant, the mesquite tree, that I think people around here think showed up with cattle drives, 500-600 years ago. But he was saying, no, we've had digs out here where we find, charred root remains or that are 5, 6, 10,000 years old. So when we talk about what's a native species and where does it live in, I think the time element of this is so interesting when we think about climate, when we think about how things change over time.
It's really fascinating. And again, I think just like everything, you have to be careful. You have to study. And so, what's interesting is, and again, I'm a big proponent of native bees, and I really love, and I used to study native bees as well. But what's interesting is, and again, honeybees, the species here that's now, is not native.
Right.
But if you go back 5-7 million years ago, there's this fossil from Nevada of an apis.
Huh.
So apis was in North America just way back then. Now it went extinct at some point for we don't know the reason.
Sure.
And then and so that's it's fascinating in that regard. So I guess what would be best to note is that obviously everything's changing.
Right.
It's simple, and so what we sort of think is it's always been there or is not the case. You could do the same thing with lots of things. Like the dominant sharks that exist today in the oceans are Carcharodontiformes, which are the requiem sharks.
Mm-hmm.
Things like white tips and bull sharks, and that those are sort of most specious, and they sort of are very ecologically important. Before them, it was the lamniforms, and so lamniforms are there are not as many today, although there's sort of the charismatic ones as well. So those are things like thresher sharks, and great whites, makos, and they were dominant, during the Cretaceous and before.
Mm-hmm.
So it's interesting that these, again, so what the group that's dominant now in many cases is often the up and coming, the new kids,
right?
And so and some of these relational things were the ecological dominance in the past, which is interesting. So
So I have a question, and feel free to tell me if this is sort of out of your field of study, but it leads to a question in my mind, and I think it's maybe part of all this. So when we think about observing things like climate change, when we look at the way that species are progressing or regressing, if we're losing, and I don't mean evolutionarily, I mean population wise, right? We're seeing species die off in insects and all kinds of things. What can studying paleobotany and old plant systems tell us about today and maybe our future?
So I think, I'll first preface that some of this, I'll probably be stepping out of some of this. I do think what is important from understanding deep time is how, and I was not a cop, but how unique and amazing these lineages are.
Yeah.
And what a travesty it would be for these things to go away after existing for so long. And it's basically being able to peer into deep time. Mm-hmm. It would be a shame. I would think also that in some of these lineages, yes, some of these lineages with climate change are going to be winners and some of these are being losers. It would be a big shame for us as humans to be the ones to determine who are these winners and who are these losers. And particularly doing it haphazardly and in many cases, not ever even understanding the true what you lost or what the treasure was that. Yeah. And so that's sort of a huge. I think it's hard today with things like habitat destruction and stuff like that. Mm-hmm. I don't think we really know what our full magnitude is in terms of what we're going to be doing. Yeah. Because again, the planet's fairly hardy and can take a lot of punches and get up, but we're doing a whole lot of punching right now. That's really, and that's not a good thing. Yeah. So it's these forests that hold so much biodiversity. Part of the arguments are, they may be beneficial to humans because they may have species that have chemicals and stuff that help us fight disease, or they have, there's some genetics that can help in these ways. Which I understand that, but I think you also want to preserve them. As maybe a museum person, you want to preserve them just because they exist. They're fascinating. They're they're beautiful in their own right.
Yeah.
So there's that too.
Yeah, no, that's interesting. I think that's a good answer. That it gives us some context, but also, what a shame it would be.
Yeah.
What a shame it would be. And you brought up the museum part, and I think that's actually a good segue. Let's take a quick break. When we come back, let's talk about the Tech Museum and what y'all do here. Some of the species you have represented here, and some of, I guess, the outreach and educational efforts you do. Well, hello there. Welcome to the mid-roll. Thanks for sticking with me through the first half of this episode. I, again, could talk about dinosaurs, paleontology, and museums all day, and hope you're enjoying it too. Thanks for being a part of Planthropology and what we do here. Thanks for listening. Thanks for your support. There's a lot of ways to support the show. If you want to tell more people about it, go do that. Tell them with your face. Word of mouth is still the best way to talk about a podcast and to spread it around and to get new ears on it. If you want to share on social media, I am Planthropology all over the place. I'm also the Plant Prof all over the place. Make sure you're subscribed on your favorite podcast player as well as on YouTube and different places. If you'd like to financially support the show, there's a lot of ways you can do that as well. You can go to planthropologypodcast.com, and in addition to finding all things Planthropology, you can grab some cool merch. You can go to buymeacoffee.com/Planthropology, and for the price of a cup of coffee, you can help me pay for, things like hosting fees and coffee. If you are listening on Spotify or Apple Podcasts or anywhere else that you can leave a rating or review, I think a 5-star is delicious. And it was just my birthday last week. And so if you're like, oh, I wish I had gotten him something, you can get me a 5-star review. That would be wonderful. It helps get more ears on the show, and it makes me feel all warm and fuzzy inside. If you like what we're doing, send me an email at planthropologypod@gmail.com. Tell me I'm doing a good job. Tell me I'm doing a bad job if you think that I am, and make suggestions for future guests. Just say hi. I like it when people say hi. That is a wonderful thing. And, but again, mostly just thanks for listening. Thanks for being a part of all of this for the past nearly 6 years, which is just crazy. We're going to have to do something big in November for the 6-year anniversary of the show. More on that later. But for now, let's get back into this conversation with Dr. Aaron Pan, and let's talk a little bit about palm trees and a bit about museums. You mentioned over the break that you actually did some work on palms as well. And before we get into the museum stuff, I think that sounds really interesting. So I'd love to hear more about that.
So what's cool, there's a site that we have in Ethiopia from the late Oligocene, which basically it's about 27 million years ago in Ethiopia. And what's really cool about Ethiopia and Africa back then, Africa at that point is an island continent, and so it's actually called Afro-Arabia because the Arabian Peninsula is part of that.
Okay.
So that point is sort of a little bit isolated. It's rafting and about to collide with Eurasia, and that is about to happen. And what will happen at that point is you have a big shift of the fauna that was on the continent of Afro-Arabia will meet the fauna that is in Eurasia. So when you think about today, when you think about Africa, what do you think about? What kind of animals do you think when you think of Africa?
I mean, zebras and giraffes and lions and those kinds of things.
Yep. Everything you just named is of Eurasian origin.
Really?
Yeah. So what do you think? So gazelles.
Yeah.
Antelopes. Hippos. All the big cats.
Yeah.
Meerkats. All of these things. Yeah. Giraffes. All of those are Eurasian in origin.
Huh.
So what you had back then, you have weird stuff that belongs to a group called Afrotheria. So things like hyraxes, elephant shrews, things like golden moles, and proboscideans. So elephants.
Oh, okay.
Those are and then you also have probably coming from Eurasia as well, although they came much earlier than whenever these two big large masses crashed together. Things like primates.
Okay.
And so you have, and you also, and because they fly, bats are also known from the, particularly, and actually they're known from a hanging. But what does that mean in terms of you have these big faunal transitions what does that mean in terms of the changes in herbivores or plant dispersal things and stuff like that? And so it's really cool to sort of see what does a forest look like in Africa, like right before this big transition. And what's cool, so this place is called Chilga, which you study. It's these overbank deposits of a river. So it's probably forested around there as well, but we're basically sampling this forest that's along this river. And it has those beans I mentioned earlier. Mm-hmm. There's several species. There's several genera species of that. There is a plant called cola, which actually Coca-Cola got a name from.
Oh.
So cola from cola nuts. Cola is an endemic genus that is in the related to hibiscus and the chocolate family. And, chocolates are like that.
That's interesting. Okay.
Yeah. And so it's there. It's a rainforest. It's a rainforest genus mainly found in forests. So it's there. They don't occur in Ethiopia today, which is also cool. But what we really found, which is really fascinating, is we found lots and lots of palms.
Okay.
Which you're like, okay, well, duh. I mean, of course, it's a tropics. It should be palms. What is the quintessential thing you think of when you think of the tropics? If you're thinking of vegetation.
Yeah, like coconuts or coconut palms, palm trees, and date palms.
Sitting on a beautiful beach with palm trees swinging, yeah. And so what's weird, though, Africa today is not known for palms. There are palms there. There's less than 70 species.
Okay.
If you go to, which sounds like a lot, 70 species, that's a lot, right? I mean,
Yeah.
But, we're talking about the second largest continent in the world.
Sure.
So Singapore has more species of palms than the whole entire continent of Africa. There are 1,000 species that occur in Southeast Asia, and you have over 500 species probably in the New World tropics.
Right.
So it's really, why is Africa weird? And we actually come back to this a lot. Of Africa is sort of known as the odd man out because it always seems to be different than these other regions. And so it's fascinating that we found lots of palm species. We found things called African rattans, so basically these climbing palms that have spines on them and they climb into the canopy and things like that. We have a genus called Hyphene, which is a fan palm. It's really cool because they often bifurcate.
Oh, interesting.
So most palms you think of just one single trunk, right? Yeah. But this one bifurcates, and so they can often bifurcate and then bifurcate again. So it's really
weird. Okay.
Yeah, they're often weird. And then there is later on there's sclerosperma, which is this weird palm that is a specialist in swampy environments, and so they sort of grow and they grow and they sort of form these little colonies and stuff like that in swampy soils. So we found and they're all together, which is really weird because you don't have that really much today in Africa. And so, do we know exactly why? No, we still don't know. But there are some ideas that maybe this transition, because what happens in late Oligocene to the Miocene, you basically move from the Paleogene to the Neogene. And so, at right around that time, you have this collision of Eurasia with Afro-Arabia. Mm-hmm. And so, did a lot of these palms, did the endemic fauna back then, were they the main plant dispersers and stuff like that? And then when the new kids arrive, they saw these weird palms. They're like,
yeah.
That dispersal may not have been as well, and so like that. Or was it climate change? Or is it both? The interesting thing about biological systems, as you know, is that it's often one explanation. There might be one primary explanation, but it doesn't necessarily mean that's the only one.
Right.
Like that. But it's really weird that we find these, this forest that has a lot of palms in it way back then. And what's interesting, Mush, the one that I told you about earlier, there's one palm there, Sclerosperma still exists, but we don't see things like these climbing rattans. You don't see Hyphene. You don't see some of these other stuff. So, and that's only in geologic time, that's a short period of time. 6 million years of difference. What's 6 million years between difference? So, what's going on? So it's kind of weird. But at that point, 21 million years ago, that land bridges would form. The Arabian Peninsula is connected to Eurasia, and things are flowing through. And so
That's really interesting. And you just think about, that makes me think one of the explanations or potential explanations you gave of, you introduce a new species and they don't know what to do with it. Yeah. They're like, what's this big weird fruit? Like, what do I do with this? And, I guess we see that in modern species too. I think about cane toads a lot, where they're like, we're going to introduce these to eat the cane moth, and you put them there and they're like, cane moths are terrible. I'm going to eat everything else. And so that is a human intervention in species spread and species diversity change. But it's really interesting to think about this being in a lot of ways historically a natural process too, right? You get two continents that slam into each other, and that's going to,
stuff's going to happen.
Stuff's going to happen.
Yeah. And it'll be fascinating for one.
Right.
But again, it'll be, there will be winners, there'll be losers, and then there'll be interesting things where there's sort of a mixture between things. So it's this world in biodiversity is amazing, and basically the biological processes that happen are fantastic.
Just really, really incredible. And I think actually that is another good segue into the museum world and the preservation of species and the education about it. So, talk a little bit about the Tech Museum. Like this is, and if for those of you all out there, I know we've got listeners all over the world, but if you've never been here, this is a beautiful museum. Like I really enjoy this space. So, tell us a little bit about it. What kind of stuff do y'all do here? What kinds of collections, etc.?
Yeah, so the Museum Texas Tech University it's a large museum. It's a little over 200,000 square feet, and not including like the Livick Lake Landmark, which is also part of it.
Sure.
It also includes the Natural Science Research Laboratory. It has 6 main collection research divisions. That is anthropology, art, clothing and textiles, history, natural sciences, and paleontology.
Okay.
So those are the main areas we're talking. And within that, we have 9.5 million specimens and pieces of artwork and
wow.
and collection items. So that's large. For Texas itself, we are the largest natural history museum in collection size. And all due respect to our wonderful friends at the Panhandle Plains Museum, I think we actually have largest museum footprint wise as well. And so that's really incredible. We have an amazing staff that, again, because of that many collections, because you have both the sciences and the humanities together, there's sort of something for for visitor. There should be something for everybody.
Yeah.
So, again, even if, and I don't know why it would be the case, but even if dinos weren't your thing, you can see some of our, amazing art collection and be taken away. If the Ice Age gallery is not necessarily a thing, you will be fascinated by the amazing, textile collection we have, and things like that. And the amazing thing too is that, again, our curators and the collections team, they are doing fascinating work in research. They're doing fascinating work in their programming. Besides those 6 collecting divisions, we also have an exhibits division. We have an education division. And so there's a planetarium. So again, it's really a amazing museum. It's free to the public, by the way. So I should also mention that too. So that's also to say as well. And again, while our focus is often, because it is a museum of Texas Tech University, it's not a museum about Texas Tech University. It's about Texas Tech. So what it is, though, is there is a heavy emphasis, obviously, because of where we're geographically located. Again, we often do have a high presence of collection items that are focused on the greater Southwest. So that includes, Western North America, including Mexico, and even extending into Central America.
Okay.
The Natural Science Research Laboratory, though, actually is a global perspective. And so that, includes bats from Nigeria, that includes material from Indonesia, that includes radioactive specimens from Chernobyl. We have, the other piece about it is that we have items that are from similar climates for other collections as well. So besides just greater Southwest sort of being our focus, and Lubbock area and stuff like that, semi-arid and arid environments.
Okay.
We have material from Central Asia, things like that. Yeah. And so, no, we are a resource for the community. We're a resource for researchers, here and around the world. We are always want, people to come in and see our amazing things. And then also, we have some really great programming that's both outreach and engagement. So we do a lot of things, and we're excited about it. Right now, if you walk through the museum, you will see an exhibit on quilts from the 1700s to the early 1900s. You will see a temporary exhibit on two-stroke Yamaha motorcycles from the 1960s through the 1980s.
See, that's so cool.
We have an exhibit right now celebrating the 20th anniversary of the Sacagawea dollar. And then,
Interesting.
And then I love its place in that because Glenna Goodacre, who was the artist for the image of the obverse image of Sacagawea and her son John Baptiste on the back of it, so there's already a piece of that too. And we have our permanent galleries again with our amazing art, and then our galleries on paleontology, because we actually go back from right around. We're really lucky being in this area. We actually are from a time period. We actually do collect stuff that's from the age of dinosaurs. Now, a lot of what we're doing, though, environmental-wise, is more wetlands, and there's not as much of the dinosaur. But we have really cool members that are related to crocodilians, to basically giant amphibians that would have been like the most terrifying salamander-looking thing you would have ever seen in the world. We have Postosuchus, which was a large terrestrial predator that actually ate little dinosaurs during the period of time. It's one of those ones that they actually show on, I think, that when walking with dinosaurs that were programmed long. Yeah. And so, it's a really great museum. And so
cool. So your big exhibit that's right out here, the three dinosaurs. There's what, a pterosaur?
Yeah, there's Quetzalcoatlus.
Quetzalcoatlus. Okay.
And there is Triceratops, and then there's a Tyrannosaurus.
Okay.
So that one again. That's much more a Texas type of thing. And we do, and that material is known from Texas, although it's from far west Texas and sort of the Big Bend area.
Right.
The stuff that's more locally known is from the Triassic period.
Okay.
That's the start of the age of dinosaurs and age of man, and actually start of the mammals too. Both sort of dinosaurs and mammals are sort of show up around the same time.
Okay.
So, yeah.
That's really interesting. So I have to ask, there recently, and I don't know if y'all are involved in this at all, but they're digging a highway south of town, and they had to stop a dig because they found bones from a sloth
giant ground sloth. And so they're our anthropology division is doing some amazing work with TxDOT, and so they're working with them. And actually, that material's here at the museum.
Oh, cool.
So it's pretty impressive. As I said, I think in terms of natural history collections, I ran the numbers because, I try to run the numbers. I think we're number 19 in the country for the size of the collection.
Oh, very cool.
For natural history. And so that is, and that's with, the Smithsonian, number 1, the Museum of Natural History, number 2, Bishop, these other museums. And so we are quite large. And no, we always welcome, people to come see what we do here and enjoy. So
very cool. So what's on the, this may be sort of just speculative, but like what's on the horizon for the museum? Like what new things are coming up?
Well, so big thing we're doing is, we are under the Office of the Provost, and we're under an area called Outreach and Engagement.
Right.
It also includes the National Ranching Heritage Center. That includes Junction down in Central Texas. That includes the Texas Tech Press, and includes the Osher Lifelong Learning Center. Okay. But a big heavy piece is we're growing our programming, and so that'll be big. And so in terms of community engagement and those type of programs, and so we're really that's a big heavy emphasis that we'll be doing. We are again still pursuing research in these areas, and so we're excited about that. And then we have some really great exhibits coming up. Well, not that we already have some really great.
right.
Everybody, please come see, our exhibits now, including the new Yamaha one, because
That's pretty cool.
We've never had a motorcycle one, which is kind of cool. But we have one on guitars in the fall. We will be having the exhibit Dressing the Abbey, which will actually be bringing in over 30 wardrobe pieces from the Downton Abbey.
Oh, interesting.
Yeah, series will be here, and so actually those were actually ones that were in the series itself. So so we're talking about that will be here in late January through of April of 26, and so there's always good stuff. We have art on, and I don't know when this will run. Art on the Yana will be, I think, next week and stuff like that.
Oh, okay.
So, yeah. So no, there's always something here at the museum, and so
very cool.
Yeah.
Very cool. Well, I appreciate it. Again, I've learned a lot. I'm always interested and I get nerdy about this stuff. And I probably have 100 more questions, and I'd love to have you back on sometime to maybe pick one of the topics and do a little bit more of a deep dive. But a couple of things I always ask my guests, just in general. You've had a diverse career, but you've kind of done a lot of cool things. If you had a piece of advice for our listeners, we have a lot of students that listen. We have people in the sciences, across the sciences, like whether it's career wise or just life wise, like what would you want someone to take home with them?
That's hard.
No, I know. I didn't warn you either.
No, that's like, I think I'm going to say three things.
Oh, sure.
Because I can't pick.
That's fine.
Which may be saying something too. So
no, that's fine.
One, I think, is you need to try and find a little joy every day, no matter what. Even if it's a hard day, something like that, you need to find some joy, and whether that is, getting a good snack or meal or something like that
sure.
during the day, if it is taking a little time at the end of the day to read a favorite novel or book or something like that, or even call up a friend or something like that. I think that's important.
Okay,
because I think that's the thing where I think everybody's so stressed now.
Mm-hmm.
You've got to really do something like that to sort of to sort of help that. I would say that. And, I think we're both biased in this because we both like, biology and
sure.
stuff like that. I think, going outside and observing and just walking in nature, and it doesn't necessarily have to be like, an unadulterated forest or a stream or something like that. It can just be, walking outside and walking to a park or something like that and just observing stuff like that. I think that's a key piece as well, because it moves you to observe things and, things that you wouldn't expect before. And there's these little micro activities that are occurring all over the place, which is fascinating. And I think that's good for people to know. And third, I would say, is lifelong learning. Key is lifelong learning, because again, it is just like with muscles. If you're not using it, it atrophies.
Yeah.
And if you're not using your brain,
yeah,
it atrophies. So learn something new every often and persistently. And so I'm hoping that no matter what, I'm always going to be trying to learn new stuff. And again, and then learning is easy when it's like it's something you really like or something like that. But learning other stuff is when it's because of challenging and stuff like that. You know what I mean?
For sure.
Yeah. So I think that those are all sort of key pieces. I don't know. It works for me. Others will have other, and again,
sure.
There's someone who are probably who have better advice than that. But.
No, I think that's great advice. I really do. And, I think that those are things that I find valuable as well, and so, no, that's great. Where can we find you and or the museum? Like if people want to learn more about what's going on.
Oh, absolutely. So there's a website obviously for the museum that they can go to. There is, we're on 4th Street in Lubbock, Texas, something like that. And on the website, it actually has our contact information, so you can get a hold of me by email or phone if necessary, things like that. And so, and we're always open for to help. Again, the other thing too is we've got a lot of experts on staff. So again, things like if people find cool plants or bugs or rocks or fossils,
right.
or they have amazing objects that they want to kind of find out about. We're there to help. if we can't provide it, we do know if we can't necessarily provide that help directly, we know who you may be able to contact about that kind of thing.
Okay.
So that's always the thing too. But yeah.
Very cool. Very cool. Well, thanks for having me out. I like any excuse to come over here. I don't get over here as much as I should. And I need to bring my son out here soon again. It's been a couple of years, and
yeah, absolutely.
I think we need to get him out of the house this summer. So it'll be good to bring him up here. But thanks again for your time. We'll have to have you back on sometime and talk a little bit more about some of the paleobotany stuff. But I really appreciate it. It was a lot of fun.
Thanks, man.
Can I just say at the end of this that I love the phrase and the concept of deep time and the long time scale of our planet and of our world and of our nature and all the things we can learn from deep time and learn from people like Aaron. So, Aaron, thanks so much for being on. I cannot overstate how much I enjoyed that conversation, how much fun it was, and we're going to have you back on soon. And thanks to you, the listener, for putting this in your ears for 120 plus episodes and nearly 6 years for some of you. There are a lot of you that have been with me from the very beginning, and I cannot tell you how crazy that is to me and how much it means to me. I love you all dearly, and I'm just so grateful that you're here. So, Planthropology is written, produced, directed, whatever other things go into a podcast by yours truly, Vikram Baliga. The intro music and outro music is by the award-winning composer Nick Scout. Our mid-roll music is Yarrow by my buddy Rui and his lo-fi Dad Beats, which you should definitely go check both of them out. They're fantastic people. I didn't mention this at the top of the episode, but this is actually the last episode for the first half of this season. I think I mentioned earlier in the year that I'm starting to go with a seasonal sort of approach to the show, and I'm just taking a planned summer break. And this episode came out a little bit later than I wanted, but I'm going to take most of July off and probably at least half of August. So look for a new episode around August 21st, 2025, if you're listening to this as it comes out. If you're listening to this in the distant future, you can probably just push next and listen to that. But I may release some bonus content. Follow on the socials for more stuff. But new episodes will be out in August, and I hope to see you then. So thanks for everything. Be kind to one another. If you have not to date been kind to one another, give that a try. My goodness, do we need that right now? Just some basic human kindness. So give that a shot. Keep being kind, keep being safe, and keep being very cool plant people. And I will talk to you real soon.